Today's lesson is over the surface area of prisms and cylinders, and the goal is to find the surface area of prisms and cylinders. Start as always with vocabulary. We have a net. This is a two-dimensional pattern that forms a solid when it is folded. Or as I like to think of it, the unfolded version of a three-dimensional shape. So for example, we're looking at a square pyramid here, and it unfolds to look like that. Use some imagination, all right? Imagine holding a folded up shape in your hand and undoing it. You would get one of those two drawings. And the surface area is the sum of the areas of each face. So, you have to find the area of this triangle, this rectangle, this triangle, this rectangle, this rectangle. Okay, all 5 faces you're finding the area for. So we're going to start here. So we're going to find the surface area of the following polyhedrons. Okay, polyhedrons just means a multi-sided shape, three-dimensional shape. So we've got this rectangular prism on the left here. This looks like a shoebox or some kind of game box. And we're going to find the area of each of the faces. Now what's nice with this is that each face has an exact match or exact counterpart. For example, the 15 right here, that refers to, the bottom dimension, this width. And then if we were to find this height, that's 15 as well. Okay? So this part, I'm going to call it the right side, is 15 by 15. Just like the side back here, you guys can't see it. Okay? The exact opposite of that, that's also 15 by 15. So we've got two sides that are each 15 by 15. Multiply them together, we get to this 15 is 30 times 15. We've got 450 inches. That covers, I'm going to call the left and right side. There's the right, and the left is over here. Now I'm going to focus on the front and back, okay? I'm calling this the front. Now see the back is going to be back there. Well, the dimensions of the front are 30 by 15. Okay, 30 by 15, and as are the back. We've got 2 of those, so let's multiply it by 2. Okay, 30 times 15 equals 450. We double that. We've got 900 for the front and the back. Finally, we have our top and our bottom. Okay, we know that this 30 going across the same as down here. So we have 30, and then this part we know is 15. Okay, it's the same as this. So again, we've got 2 by 30 by 15, same as the front and back dimensions. And again, we have 900. We add these all up for a total surface area of 2,250 inches. I'm sorry, square inches. Okay, you're dealing with area. Try that over here. Now we have a triangular prism. Little trickier, but nothing we can't handle. So we're going to find all of our faces again. So I'm going to go with the bottom one here to start. Okay, that base down there, that's 15 by 10. So that face has an area of 150 centimeters squared. Then I'm going to look at, I guess the way we're looking at the right side, which is right here. That's going to be 15 by 13. Okay, and this matches up, the one that's right here, is the same as the one, we can't really see it, it's kind of in there. So we've got 15 by 13, we're going to take that twice. 2 times 15 is 30, 30 times 13 will be 390. So we've got 3 of our 5 faces already covered, okay, the 3 rectangular parts. Well, now we've got our triangular bases, and these are also going to be identical. Okay, so we've got the base of a triangle is 10, and we're given the height of the triangle as 12. Now we know the area, right? 1/2 times base times height, and there's 2 of these. Well, use our number sense. We know we can multiply in any order we want. Well, 2 times 1/2 cancels out, just becomes 1. So don't have to worry about that. 10 times 12 is 120. we go ahead and we add all those parts together. Again, using some mental math here, 150 and 390 makes 540 plus 120 equals 660 centimeters squared. So that covers prisms, okay, triangular and rectangular. Now we're on to cylinders. Okay, here's that circle lesson the day before. If it was review or not, it comes in handy. So we have a cylinder here. Okay, kind of a funky net when we draw it. We definitely have two circles, okay? The top and the bottom. And we're kind of left, you know, with a curved, almost rectangular, you know, body of it, okay? We have, you know, right here. But we've got to account for those circles at the top and the bottom. Okay? But we're going to look at it as a rectangle. Okay, because it really does, you know, kind of come together that way. So, area of a rectangle, just our base times our height, length times width, however you want to say it. Now, the length of the rectangle in the middle is actually curved to fit the outside of the circle. So, the distance around the outside of the circle, we know that is called circumference. I want to backtrack for 1 second, I guess, to match up with the term length that's bold-faced here. We can always call the rectangle, you know, length times width for the area. I'm sorry for that. Now, how do we find the circumference of a circle? Well, from the previous lesson, we know that is going to be pi times diameter, or 2 pi r, based on your preference or what's given to you. Now, if you have a circle, okay, again from that same lesson with circumference, we know that's going to be pi r squared. So we're going to put everything together for the surface area of a cylinder. Okay, we've got two circles that we got to find the area for. So that's 2 pi r squared. Now, we need to account for the height of the cylinder. Okay, so that's pretty important. As well as that circumference that we need to find. And since we have radius in the first part of the formula, I'm going to keep radius right here. Okay, so we're taking the circumference times the height. All right, that's kind of what's happening here. The circumference, put two halves together to make one whole circle, times the height of the cylinder. I'm using my finger to point. It's not really helping us here. So let me show it again. Okay, we put these two halves together. We get one circumference of a circle, and we have the height to go with it. That is where that 2 pi RH comes from. Ask me in class in person to make that more clear. I know it's not the easiest over video, but that is your formula. So we're going to apply that formula to this cylinder to find the surface area. I cannot stress enough to you guys to write out the expression. Okay, what should we be plugging in? A lot of parts here. All right, it's easy to get confused. You try to do it all in your head. So write out the formula, then just chug and plug. So we're going to use 3 14/100ths for pi. The given radius is 8. That is the radius, I promise. You can't see the full line, but that's just showing there. And the height is 20. Okay, just plugging away. Okay, so to save some time, I'm going to go ahead and use my calculator to find all of this. So the left side, 2 times 3 14/100ths times 8 times 20 becomes 504 4/10. And then on the left, we have 2 times 3 14/100ths times 64, because 64 is 8 squared, equals 401 92/100ths. And we add those two parts together for a grand surface area of 906 and 32/100ths. So we spent a lot of time there, you know, trying to build the formula up. But once you have the formula, you're just plugging and chugging away. This concludes your lesson over surface area of prisms and cylinders.